So for my question, we are told to evaluate, or rather, we are told to evaluate the given surface integral where the surface is a helicoid. And this is that surface here. This is the function of that surface. Square root 1 plus x squared plus y squared ds. With vector equation r, u comma v, which we are given here. And then we are given the closed intervals for u from 0 to 1 and for v from 0 to pi. So for any surface S that's given parametrically or by a vector valued function, which is defined over a region R, and the region R is usually the projection of this vector valued function onto the UV plane. We write it as the double integral over the surface S of f xyz multiplied by ds equals the double integral over the region R of f expressed in terms of u and v. So f uv or xuv, yuv, zuv multiplied by the magnitude of the cross product of the partial derivative with respect of r with respect to u and the partial derivative of r with respect to v times differential a. So basically what this really means is we are taking our integrand here, we are expressing it in terms of u and v, and then we are multiplying it by the magnitude of the partial derivative of the partial derivatives with respect to u and v crossed. So basically we are crossing the partial derivative of r with respect to x and the partial derivative of r with respect to y. So we are crossing them together, and then we are finding the magnitude, and then we are multiplying that with our integrand here expressed in terms of u and v. So let's first write this integrand here as a function of u and v. And the thing to realize here is that our vector valued function here r uv, which we are given the values here, that this u cos v is our x value, u sin v is our y value, and u is our z value. V is our z value. V, this should be v. V is our z value. So we have it right here. So r uv equals to u cos v, u sin v, v, and these are our x, y, and z values. So basically we just substitute this into this integrand here. So we are going to have 1 plus x squared. So x is u cos v. So u cos v squared, and we have it here, and y squared, u sin v squared, we have it right here. So when we simplify it out, we are going to get our fuv value. So basically it's not fxy, it's fuv. We have expressed our function in terms of u and v equals the square root of 1 plus u squared. So that's the first step. Remember, this is the first part of this formula here, which is we find fuv, we multiply it by the magnitude of the cross product of the partial derivative of r with respect to u by the partial derivative of r with respect to v over the region dA, or rather times dA. And so let's find the partial derivatives of r with respect to u and v. So the partial derivative of r with respect to u, we are going to come here to our R, U, V values, and we are going to find, actually they are right here, U cos V, U sin V, and V. So R, the partial derivative of R with respect to U will be cos V, because we are doing U cos V. So U is the value that we are finding the derivative. Cos V will be a constant, so it's going to be cos V. The same thing here, sin V will be a constant, and then the derivative of U with respect to U will be 1. So we have sin V, and then V, the derivative of U, the derivative with respect to U, the derivative of V with respect to U is 0. So we have 0 there. And then we come to our partial derivative with respect to V, which is going to be, so for U cos V, we are going to find the derivative of cos V, which is minus sin V, and then we multiply it by this constant here, so we are going to have minus U sin V. The same thing with U sin V, the derivative with respect to V will be U cos V, and then the V, the derivative with respect to V of V is going to be 1. So now we have our R sub U and our R sub V. Now we can find the cross product of these two here. And when I did the cross product of these two, I found, or I got, sin V minus cos V and U. So this is our I value, our J value, and our K value. Now since we found this cross product, the next step is to find the magnitude of our cross product. And this is the magnitude of our cross product, which is basically sin V squared plus minus cos V squared plus U squared. And when we simplify it, we get the square root of 1 plus U squared. Now we have both sides of the equation. We have F, U, V, and we have the magnitude of R sub U, and R, we have the magnitude of the cross product of R sub U and R sub V. So now we just multiply those two together, and we are integrating over the region, over these limits here, from 0 to 1 for U and from 0 to pi for V. So 0 to 1 for U, 0 to pi for V. When we multiply these two, we get 1 plus U squared equals 1 plus U squared du dv. And then we just integrate normally. So the first order of integration is with respect to U. So 1 will be U plus U squared, it's U cubed over 3, and then bracket. The limits are from 0 to 1, and then we can just plug in the 1 everywhere where we have U, and the 0 everywhere where we have U, and then we find the difference. And when we do that, we are left with this 4 over 3 dv, and we integrate with respect to V from 0 to pi, which is our other limit of integration for V. We do the same thing. We have 0, pi, so everywhere we have V, we substitute for pi, and 0, we find the difference, and we finally find the answer to be 4 pi over 3. Thank you.